From the previous video, we were able to derive parametric equations. Now this time, here in this lecture video in Differential Calculus, we will solve the sample problem under the topic curve tracing. So here is the instruction. Obtain all critical points, determine the maxima minima by the test, and find inflection point or points from the parametric equations given. Now, this topic has already, or this finding the critical points has been discussed in the previous videos, but the difference now here is that we are doing parametric equations. Now observe that we have there the third variable t, so we will remove that one. Okay, so having this as the first equation and this is the second equation, we will again find the first and second derivative. So just as the process that we have discussed in the previous video. So first we have the dx over dt, that becomes 3t squared plus 0. So dx over dt is, let's use this portion here. So this is 3t squared for the dx over dt. For the dy over dt, we have 8t minus 4, or that could also be equal to 4 times 2t minus 1. Okay. Now for the derivative, first derivative, we have dy dt all over dx over dt. The value for dy dt is 4 2t minus 1 all over the value of dx over dt, and that is 3t squared. Cancel out the t. We now have dy dx, which is also equal to y prime, is equal to 4 2t minus 1 all over 3t squared. So that is for dy prime. Now for the second derivative, okay, so solving for the second derivative, we have here the derivative of dy over dx with respect to t, multiply it with dt over dx so as to cancel out dt and get a value d squared y over dx squared. Now first, let's derive this. So that is derivative of e quotient. So 3t squared. Then the derivative of numerator, that is 4. The derivative inside will be, that becomes 2 minus 0. Okay? Minus 4 2t minus 1, then derivative of 3t squared is 6t. Lower the square of the lower part multiplied 2 dt over dx. Okay, then let's have this. So this is 4 times 2, that is 8. 8 times 3, that becomes 24. So that is 24t squared minus, this is 4 times 2, 8. 8 times 6, that would be 48. So negative 48t squared plus, because we have there negative 4 times negative 1, that is positive 4. Positive 4 times 6, that is 24. 24t. Okay, I think we got it right. So that is divided by 9t raised to 4 multiplied with the dt over dx. What's our dx over dt is 3t squared. So the reciprocal for dt over dx, that would be 1 over 3t squared. So that is now, so that is equal to 24, so negative 48 plus 24, that is negative 24t squared plus 24t divided by, it's 9 times 3, 27, t raised to 6. That is now equal to negative 24. So let's bring out negative 24t. That is t minus 1. Yeah. That is divided by 27t raised to 6. So our d2 y over dx squared, that is also y double prime, is now equal to, we cancel out the t, then okay, divide 24 with 3, divide 27 with 3, so we have negative 8 t minus 1 all over 9t raised to 5. So that is the second derivative. So now that we have the first and second derivative, let's proceed to the next step for the critical points. For critical points, we have y prime, or set y prime is equal to 0. So previously we have our y prime is equal to 4 times 2t minus 1 all over 3t squared. So let's copy that one here. Y prime is equal to 4 times 2t minus 1 all over 3t squared. And then we will set y prime is equal to 0. Okay. So what is 3? The denominator multiplied with 0. Of course, that will be 0. What will be 0 divided by 4? That will be 0. So what's left will be 0 is equal to 2t minus 1. 2t is equal to 1. So t is equal to 1 half. So we were able to get a value for the parameter t. Then, for us to have a critical point, we substitute t equals to 1 half to the original equation, the equations 1 and 2. So remember that we have a given equation here, the x and y. So finally, having the value for t, we will obtain points for x and y. So we will just simply substitute the value of t. So the original equation is x is equal to t raised to 3 plus 1. Substitute the value for t, which is 1 half. Then we have the value of x is equal to 9 over 8. Now for the y, so we have the value for y, for the equation for y is, is 4t squared minus 4t. So 4t squared minus 4t, substitute the value of t, 1 half, 1 half. So y now is equal to, cancel out the 2, okay, so negative 1. Y is equal to negative 1. Therefore, CP is at 9.8, or critical point is at 9.8, negative 1. So that's what the instruction is. Find the critical point or points. In this example, we only have one critical point. The next one is to determine if that point, the critical point, is either maximum or minimum, or maxima or minima. Then after that, we will be looking for the inflection point. So we are looking for the 3 critical critical point, maxima minima, and inflection point. So let's continue here. Having the value for CP, check for maxima minima. Check for max min. By the test, for maxima minima, if you recall, so we will be using the y double prime. So the value for y double prime a while ago is negative 8 t minus 1 9t raised to 5. So that is negative 8 t minus 1 all over 9t raised to 5. Now if you recall, if we substitute the value of t here and the value for y double prime is positive, that means it is the minimum point. If the value turns out to be negative, that is the maximum point. So let's check. Okay, so substitute t with 1/2 because that's what we used to get the CP or the critical point. So that's why we are substituting t is equal to 1/2 minus 1 all over 9 times 1/2 raised to 5. So using your calculator, you will be able to obtain y double prime. So y double prime is 128 over 9. It is positive, therefore it is minima. The point is at a minimum point. Now, finally, the third one, we are looking for the point of inflection, the PI. For point of inflection or the inflection point, so if you recall, we will just set y double prime is equal to 0. Now let's copy the y double prime here. So y double prime is equal to negative 8 t minus 1 all over 9t raised to 5. And then we will just set y double prime into 0. So that is 0. Okay. So if we multiply the denominator with 0, the answer will be 0. If we divide 0 with negative 8, the value will be 0. So what's left will be t minus 1. Therefore, we get another value for t, and that is 1. So meaning, when we are looking for the inflection point, we will not use the value t is equal to 1/2 because that value of t is for the critical point only. So what we get as the value of t when we set y double prime with 0, that value of t is for the inflection point. Okay, I hope that is clear. Now, again, for us to get a point, so we substitute t is equal to 1 to the equations 1 and 2, wherein x is equal to t raised to 3 plus 1. So we substitute t with 1 raised to 3 plus 1. So x is equal to 2 for y. So y is 4t squared minus 4t. Then we substitute t with 1. The value for y is equal to, that becomes 0. So therefore, the point of inflection is at 2, 0. So this is now the answer. So we were able to locate the 3 being looked for. This is for number 1. Next, let's have the example number 2. So we are looking for the critical points or point of and test for maxima minima of those critical points and find the point of inflection of these parametric equations. So that is x is equal to t raised to negative 2, y is equal to t squared minus 4t plus 1. So this is our first equation. This is our second equation. Again, let's find the dx over dt. So that is negative 2t negative 2 minus 1. So that is negative 2 raised to negative 3. So that is for dx over dt. For dy over dt, we have 2t minus 4 plus 0. dy dt is now 2. That is t minus 2. Okay. Next, we have the dy over dt divided by dx over dt in order to obtain the first derivative. So we now have here the value for dy dt is 2 times t minus 2 divided by the value of dx over dt, which is negative 2 t raised to negative 3. Cancel out dt. We have the y over dx. So cancel out negative 2. Then since this is negative, it has negative powers, meaning it does not belong in that place. Therefore, it is not a denominator. It will become a numerator. So that is negative t raised to 3 t minus 2. So that is our y prime. Okay, now let's look for the y double prime. We have there the derivative of dy dx with respect to t multiplied with dt over dx. That is equal to derivative of a product. We have negative t raised to 3. Then derivative of t is 1 minus derivative of 2 plus t minus 2. Then derivative of d negative t raised to 3 is negative 3t squared. And then we have there, multiply it with dt over dx. Now we will cancel this one out. What's left is d squared y over dx squared. That is equal to negative t raised to 3 minus, that is negative 3t raised to 3 plus 6t squared multiplied with the value for the dt over dx. For the value of dt over dx will be the reciprocal of dx over dt. So multiplied with 1 over negative 2t raised to negative 3. Actually, this one should be in the numerator, but well, let's just put it like that for the meanwhile. So this is now equal to negative 4t raised to 3 plus 6t squared multiplied with negative t raised to 3 all over 2, then distribute. So that becomes positive 4t raised to 6 divided by 2 minus 6t raised to 5 divided by 2. Therefore, here we have now d squared y over dx squared, or that is y double prime, is equal to, so we cancel out 2, then let's remove t, 5. That is 2t minus, cancel this one, this becomes 3, and remove t. So that is the y double prime. Next, for the critical points, for CP, let's just write CP there. Y prime is equal to 0. Let's copy the value for y prime. Y prime is equal to negative t raised to 3, and then we have there t minus 2. Now we have there 0 is equal to negative t raised to 3, and then we have t minus 2. Right. So we have here, we can have actually two values. The first one is if we divide 0 with negative t raised to 3, the value obviously will become 0. So what's left will be 0 is equal to t minus 2. And then let's name this t sub 1. So t sub 1 is equal to 2. The other one will be, so let's put it here. So the other one is if we divide 0 with t minus 2, what will happen? The value will be 0 is equal to negative t raised to 3. Then if we divide 0 with negative 1, the value will be 0 is equal to t raised to 3. So what is the answer here? T2 will be equal to 0. So substitute. I'm curious about this one here. Let's try that. Substitute T2 is equal to 0 to equations 1 and 2. Let's find out. Remember that we have the value for x is, we have the equation x is equal to t raised to negative 2. So if this is also similar with 1 over t squared, so x is equal to 1 over 0. So undefined. So we cannot use t squared at t is equal to 0 because x here will be undefined. So let's erase. Meaning the only one that we will be using here will be the t1. So there is no t2. Okay. Because if we use the t2 is equal to 0, the value will be undefined. So let's just stick with t is equal to 2. And then substitute it to equations 1 and 2. X is equal to, so that is t raised to negative 2. That is 2. So x will be equal to 1/4. While y is equal to t squared minus 4t plus 1. Substituting here 2 squared minus 4, 2 plus 1. Using your calculator, you have there the value for y as negative 3. Therefore, critical point is at 1/4 negative 3. So this is the critical point, only one. Next, let's check for max min. Then we have their y double prime. So So what is our y double prime a while ago? So t raised to 5 2t minus 3. That's, yeah, t raised to 5 2t minus 3. Okay. Then let's substitute. The value for t that we use here is 2. So that is 2 raised to 5. 2 times 2 minus 3. So that is equal to, this is 4. 4 minus 3 is 1. 2 times 2. 4 times 2, 8 times 2, 16 times 2, 32. Positive 32. Therefore, it is minima. Okay. Next, we have the point of inflection. For Pi, y double prime is equal to 0. So our y double prime is t raised to 5 2t minus 3. Set y double prime equal to 0. So t raised to 5 2t minus 3. Again, we can have two values for t here. If we divide 0 with t raised to 5, value of course is 0. So we have there 2t minus 3. 2t is equal to 3. Therefore, t1 is equal to 3 over 2. For the other one, so we have there, if we divide 0 with 2t minus 3, we have there 0 is equal to t raised to 5. T is equal to 0. Now, remember, we try to substitute this value of t a while ago in the x equation, and the answer is undefined. So again, we will not use that. We will only be using t is equal to 3 over 2. Okay. So having the value for t, substitute to equations 1 and 2. So x is equal to t raised to negative 2. That is 3 halves raised to negative 2. X is actually equal to 4 over 9, reciprocal. Next, y is equal to t squared minus 4t plus 1. That is 3 over 2 squared minus 4 times 3 over 2 plus 1. So this is 9 over 4. This is cancels, becomes 6. That is negative 11 over 4. Negative 11 over 4. Therefore, Pi is at 4 over 9, negative 11 over 4. Okay, so that is the answer. That is for example number 2, our last example. Okay, so that's all for this video.